Okay, so we have these two equations, 5x minus 2y equals 27, negative 3x plus 5y equals 18, and they want us to solve using matrices. So I've converted it already into matrix form. It's inside a matrix, and this is our goal over here in yellow. We want to get diagonal ones, we want to get a 0 under the 1, and these ABCs are just integers or any real number. So the first step, what do we want to do to the first row? Again, I'm going to label this row 1 and this row 2. This 5, we want to make that into a 1. So the easiest way to do that is to divide all of row 1 by 5. So we're going to take row 1, all the elements, these are elements, they're called elements, all of the elements of row 1 and divide it by 5. To change what row again, it's really, sometimes it's a good idea just to write right here like what row we are changing. To change row 1, only row 1 is going to be affected. So let's write our new matrix. So if we take 5 divided by 5, that's 1. Negative 2 divided by 5 is negative 2 fifths. And 27 divided by 5 is 27 fifths. And just copy in the rest of row 2. And now we have this. Our second goal. What is our second goal? You see this negative 3? We want to make that into a 0. And don't jump steps. Don't say, oh, look, there's a 5. I can easily make that into a 1 by dividing all of this by 5. I'd suggest you don't do that. Just do it in order. It's my recommendation. Um, so this negative 3, we want to make this into a 0. So let me write over here first. This is row 1 and row 2. How do we make this negative 3 into a 0? Well, it seems if we multiply row 1 by 3, so 3 times row 1, and add it to row 2, will give us 0. So let's take the element of row 1. 1. 3 times 1 is 3, and if I add row 2, 3 minus 3 is 0. That's going to give me 0. So we can do that. And we're doing that to change row 2. So let's write our new matrix. So remember, we're not changing the first row, so the first row stays the same. So, okay, so 3 times row 1 is 1, minus 3 is 0. And now we have this fraction, negative 2 fifths times 3. Okay, let's write this over here. Let's do it on the side. Negative 2 fifths times 3 over 1. I'm going to convert this in so they have equal denominators. So it's going to be negative 2 fifths times 15 over 5. That is going, wait, what am I? Okay, I did an extra step, but whatever. Negative 30 over 25. If you divide everything by 5, it's still going to give you negative 6 fifths. And if you didn't have to do this, I take that back. I don't know what I'm thinking. It's been a long day. Anyway, it's negative 6 fifths. You could have just multiplied sit across and you would have still get negative 6 fifths. Okay, so this is negative. Oh, wait. We multiplied, but we have to add 5 now. So we have negative 6 fifths plus 5, that is 25 over 5 equals 5. So now let's add that, and negative 6 plus 25 is 19. So this becomes 19 fifths, so we could put 19 over 5. Now let's do the third column. 27 divided by 5. 27 over 5 times 3. What's 27 times 3? 27 times 3 is 81. So we take 27 over 5. Let me put this so it's a new one. 27 over 5 times 3 equals 81 over 5. And we're adding 18. Okay. First of all, I'm going to divide 81 divided by 5. Alright, well, 81 divided by 5 is 16.2. So we take 16.2 and add 18. That's going to give us 34.2. Sometimes it's easier to work with decimals instead of fractions in matrices. Sometimes. So I'm going to do that. So I'm going to go ahead and convert all these other fractions just to make everything even. So I'm going to convert negative 2/5 is negative 0.4. 27/5 is 5.4. And this is just 0. 19/5 is 3.8. And this is 34.2. Okay, we got our 0. That was a bit of a tackle, but we got it. So now, what is our next goal? Our next goal is to get this 1 over here. This 1. This is column 2, and row 2. We want this 3.8 to be a 1. So we can just divide all of row 2 by 3.8. Row 2 divide by 3.8. To change, let me get the color. To change row 2. Okay, so let's see what we get. We have 1. Row 1 doesn't change, remember that. 4, 5.4, 0. 3.8 divided by 3.8 is 1. 34.2. Okay, let me take this over here. 34.2 over 3.8. Hopefully that divides evenly. 34.2 divided by 3.8. Yeah, it's 9. Perfect. And keep a calculator handy. It helps a lot. There you go. There you go. Now we can solve this. So now let's translate this into these linear equations. Okay, so we have x minus 0.4y equals 5.4, and we have y equals 9. So we have our first ordered pair. We have our first one of our solutions so far. So we don't have our x, but we do have our y, which is 9. So now all we got to do is plug in that 9 into this equation, into this one. X minus 0.5 equals 5.4. So let's go ahead and do that. I'm going to do it over here. Okay, hopefully I'll do it down here. X minus 0.4 times 9 equals 5.4. That should be 3.6. Yeah, I was right. So that's going to be x minus 3.6 equals 5.4. Now we're going to add 3.6. Ooh, that's a 5. To both sides. So these cancel out. And that gives us x equals 5.4 plus 3.6. That should be 9. 5.4 plus 3.6. Yep, that equals 9. So x also equals 9. Interesting. Okay, so we have that, and we have this. So let's plug in 9 over here as one of our solutions. That's our order pair, 9 and 9. Let's check it to make sure it's true. So I'm going to take the original linear equations and plug in these values. So 5 times 9 minus 2 times 9, does that equal 27? 5 times 9 is 45. 2 times 9 is 18. Does 45 minus 18 equals 27? Yep. 27 equals 27. So this one is a check. Let's check the second one. Should be right. Negative 3 times 9 plus 5 times 9 equals 18. Negative 3 times 9 is negative 27 plus 45. Yep. That should be right, actually. Wow. Confusing numbers sometimes, man. Okay, so we have 18. So 18 equals 18. And that's a check. And that's a check. Word of advice, If you see that most of the time, from my experience of working through matrices, through intermediate algebra and stuff, um, all the time, these fractions, they can be, they come out to be really clean decimals, like 0.4 or 0.3. They never come out to be like 0.567, like 4-digit decimal places, nothing like that. So I recommend that you, as soon as you see this, convert them to decimals. Um, just convert them. It makes easier. You see right here, I had to do 2 steps. I just converted it, and everything else just makes easier because you don't have to, but it would just save you more. It'll save you. You'll do less work when we did this part over here because you won't have to multiply both sides by the denominator and cancel out. It just saves you all that stuff. So that is our solution 9. This was problem 17, page 240. Thank you.